This MCQ is from NEST 2022 Shift 2, and in the official version available it is question number 60. A glass prism of angle beta is placed in front of two mutually perpendicular mirrors as shown in the figure below. The refractive index of the material of the prism is, take n air as 1, sin alpha upon sin beta by 2, sin 2 alpha upon sin beta by 2, sin alpha by 2 upon sin beta by 2, sin alpha plus beta by 2 upon sin beta by 2. Now look, let us start considering the direction of the propagation of the ray. Okay, let us start let's start to trace the direction of the ray of light. So here it is going to first incident on the mirror surface, horizontal mirror, with angle of incidence alpha, so angle of reflection will also be alpha. Okay, now because these two mirrors are perpendicular to each other, okay, these two mirrors are perpendicular to each other. If we imagine this particular right triangle, okay, this particular right triangle, which one? The one which whose hypotenuse here represents the direction of the reflected ray, this one, okay, this one. Okay, so if we consider that, then this angle will be alpha, this angle will be alpha, and this angle will be phi by 2. So you got a relationship between alpha and phi by 2. Alpha plus phi by 2 equal to 90 degrees. And if you multiply by 2, you will get 2 alpha plus phi equal to 180 degrees. We may need it because in our options phi is not there, only alpha and beta are there. Alright. Now let us consider the second reflection. This angle will essentially be phi by 2. Okay, let me zoom in a bit. Okay, this angle will also be phi by 2. And then at the right face of the prism, the angle of incidence is phi. Okay, at the right face of the prism, the angle of incidence is phi. Now please look here. As you see, this is our first angle of refraction. Okay, this is our first angle of refraction, this angle. Let us call this angle as R1. Then, okay, then this is our second angle of refraction. Which angle? This is the normal on the left face. So this angle will be R2. And if you consider the angle of emergence, that angle of emergence is again phi. So we have now successfully traced the ray of light through the prism. Okay, through the prism. And now our job is to figure out the refractive index. Again, apply Snell's law. Okay, again apply Snell's law. We have to apply it 2 times. First, let us apply it on the right face. So sin phi upon sine of R1 is equal to n. Okay, or whatever the refractive index of the material of the prism is. And then if we apply it on the left face where the ray is emerging out, in that case it would be sine of R2 upon sine of phi, angle of refraction, angle of, yes, angle of incidence is now R2 and angle of refraction is now phi. But this time, because it is traveling from denser to rarer, it will be 1 upon n. Okay, it will be 1 upon n. Now these two equations actually help you in determining the relationship between R1 and R2. How? Look here. Suppose we take the ratio n upon, suppose we take the ratio sin phi upon n. Okay, suppose we take the ratio sin phi upon n. From this equation we get it as sin r1, and from this, okay, if we take the ratio sin phi by n, it will be sin r2. Both are same, which give us, so the equality of sin r1 and sin r2 gives us an important relationship. Both r1 and r2 are acute from the figure, so r1 must be equal to r2. Okay, r1 must be equal to r2. That is our first conclusion, and now we are going to use it to find out relationship between r1, r2 and beta. Okay, look, let us now consider this particular quadrilateral. Okay, which one? The quadrilateral whose two sides are the normals to the faces, and then the other two faces are sections of the faces. Okay, this particular quadrilateral. Both these angles are right angles. Both these angles are right angles. What does it mean? It means the internal angles will also be right angles. So beta plus this angle, let me use a green dot here. Okay, so beta plus that green dot, that will be 180 degrees. But if you consider that small triangle, okay, if you consider this triangle, for this triangle r1 plus r2 plus green dot is also 180 degrees. So basically beta will be equal to r1 plus r2. Okay, beta will be equal to r1 plus r2. Let us now write that here. You can zoom in after, if you have any doubt, you can zoom in and check whatever relation we just now updated. Okay, first relationship is from quadrilateral. Okay, quadrilateral. Beta plus green dot plus two right angles equal to 360 degrees. So beta plus green dot is 180. Okay. Now suppose we consider that yellow triangle. Okay. Suppose we consider that yellow triangle. In that yellow triangle, what relationship do we get? R1 plus R2 plus green dot equal to 180 degrees. Therefore, R1 plus R2 equal to beta. Okay. Wait, let me paste the zoomed figure here for your convenience, for your reference. I think now you can clearly see that. Okay. But because R1 and R2 were equal, R1 and R2 were equal, can I say that R1 equals R2 equal to beta by 2? Yes, we have to say that. R1 is equal to R2, so R1, R2, both of them will be equal to beta by 2. And now we can finally go for the relation which we obtained from Snell's law. Sin phi upon sin R1 is equal to n. Okay, sin phi upon sin R1 equal to n. Okay, how did I get it? I got it from, let's call this as 1, let's call this as 2, let's call this as 3. So we have got it from 1. Okay, we have got it from 1, and let's call this as 4. Okay, we have got it. But our options do not seem to have phi. Okay, so let's call now this relationship as let me call it phi, although we got it earlier and we have named it that way. Okay, 2 alpha plus phi is equal to 180 degrees. So phi will be 180 minus 2 alpha. Phi will be 180 minus 2 alpha upon sine beta by 2. But what is sine of pi minus theta? Sine theta, right? Sine theta. So sine 2 alpha by sine beta by 2. So how did we get this? From 5. Okay, which one? phi equal to 180 degrees per day. So now do we have that option, sine to alpha upon sine beta by 2? Sine to alpha is there only in option B, sine beta. So correct option is B. So is it clear how we solved the MCQ? First of all, we obtained the relationship between alpha and phi. Then we applied Snell's law twice, one on the right face, one on the left face. Then we considered the relationship between the middle two angles R1, R2 and beta. It will always be R1 plus R2 equal to beta. And using those relationships, we finally managed to obtain the refractive index of the material of the prism.